If you run a multi-level model or linear mixed effects model, then you have to check the normality assumption. But what happens if this assumption is violated? That's what this video is about. First, to better understand the issue, let's compare regression to multi-level modeling when it comes to the normality assumption. In a regression, we have one normality assumption. That is, the normality of the residuals. For multi-level modeling, it's more complicated. We have to check the normality of the level 1 residuals, and in addition to that, we have to check the normality of the level 2 random effects. So we have to look at level 1 residuals, level 2 random intercept, and if we have one or more random slopes, add the normality for each of the random slopes. The ML algorithm assumes that all these random effects are normally distributed. First, let's look at the level 1 error terms. What if they are not normally distributed? In most cases, that's not a problem because of the sample size. Because for a large sample size, we can rely on the central limit theorem. Let's take an example. Let's say we have 20 groups and 25 persons per group. Even for this model, we would have 500 observations on level 1, probably large enough to rely on the central limit theorem. So non-normality on level 1 isn't the main issue. But what about level 2? What about a violation of normality for the random intercept or for one or more random slopes? Let's take the same example. 20 groups with 25 persons per group. Here on level 2 we have a sample size of 20. And that's quite small, so here we can't rely on the central limit theorem. What are the consequences if normality is violated here? For this I rely on Maas and Hox. You will find the full reference information in the video description. They have run simulation studies to check the impact of violations of normality on level 2. First, impact on the fixed effects. The estimates are unbiased. And the standard errors are accurate, and thereby also the test statistics and p-values. And that's very good news, because in almost all cases, your hypotheses will be about fixed effects. I'm a statistical consultant, and I haven't had even one client who had hypotheses about random effects in a multi-level model. Everyone I worked with had hypotheses about fixed effects. And they are correct, even if on level 2, for the random effects, the normality is violated. For the random effects on level 2, the estimates are unbiased, but the standard errors are not accurate. And if the standard errors are not accurate, then that applies also to the test statistics and the p-values. So you can confidently claim, for instance, yes, we have a significant random slope for a predictor, that is, the impact of this predictor significantly differs between different groups. In the words of Maas and Hox, in general we conclude that using ML methods for the analysis of multi-level data with non-normally distributed group-level residual errors only causes problems when one is interested in the significance or in the confidence intervals of the variance terms at the second level. As a summary, you should test normality on both levels. If you have a violation on level 2, then you would need to write a disclaimer if and only if you report p-values for random intercept or random slope, because those p-values could be false. Thanks for watching and see you in the next video.